The last piece of our discussion regarding distribution system valves will be about valve operations, maintenance, and practices associated with ensuring that our valves provide us the function that they're designed to achieve. So we'll start with, in terms of operation, the first is the periodic need for repairs. And as I've mentioned before, one of the biggest challenges we can have is isolation valves that don't function properly, isolation valves that don't properly isolate. And it can be due to material that's built up in an old style double disc valve. It can be due to corrosion, as you can see on the interior of this particular valve. If you take a close look at the operating nut on this valve, it's rounded, which makes it difficult to operate. So there's a whole lot of things going wrong with this valve, which is why we removed it, and we're in the process with this picture of replacing it with a brand new resilient wedge gate valve. So that becomes necessary, and it's, as I mentioned when we were talking on the linear stroke valve section, there's a whole lot of valves out there. One of the biggest challenges, one of the biggest cost factors that I'm dealing with right now at my day job is the number of valves that we have that aren't working properly, and the cost and resource allocation necessary to correct those problems. Because as you can see, this was a pretty involved operation. It was a big old hole in the street. Actually, it was, I think, 10 to 12 feet deep. We were struggling with the isolation we had even to replace this valve. So it's a big deal to go out and replace valves, and drives a bunch of cost. But again, having valves in the system that don't give us any isolation means they're just a hole in the pipe. They're just an expensive portion of the pipe, not providing any real function. So a big portion of the operation of valves is the need to repair them as they age and don't provide the same level of function or operability that they were originally designed. The actual operation of the valve, and when I say operation of the valve, I literally mean opening and closing it for whatever reason, can be done a few different ways. One is a motorized actuator. And the term actuator is what you see in this picture. You can see the valve, but the assembly on top of it is a motorized actuator that will open and close the valve. It's literally a motor that will create rotation. It still has the same 2-inch operating nut, but will rotate it by virtue of the actuation of the motor itself. So that provides a significant level of ease of operation. We're not having to turn it. It can, in this case, as I mentioned before, that plug valve that we had at the big reservoir that wasn't working anymore, this is the valve we replaced it with. This is a butterfly valve, which also illustrates the point I made earlier about butterfly valves, about the short lay length. You can see that it doesn't take up a lot of space. But in this case, to open and close the valve, it's a press of a button instead of trying to manually operate the valve. The other nice things about the concept of motorized actuators is you can operate them remotely. The picture you see here, you don't see the actuator because it hadn't been installed yet, but the valve you see in the foreground is a valve at one of our pump stations that we literally have to operate every day. It's part of the way we move water around the system, so there's times where that valve needs to be open and times where that valve needs to be closed, and it changes basically every day. So we were having to send an operator to the station every day to open and close that valve, up until the point where we put a motorized operator on it. A motorized actuator, again, is the word I want you to be familiar with. And that gives us the ability, with a click of a mouse back at our control building, to remotely open and close the valve through our SCADA system. So it provides a whole different level of efficiency when we can operate some of these facilities remotely. We also have the ability to achieve some automatic operation. So this is that same outlet system you saw on the big reservoir. And if you look in the background of this picture, you can see a motorized actuator that's on a valve on the discharge of this reservoir. So you see this is a 36-inch pipeline with a 12-inch bypass line. And the reason the 12-inch bypass line is there is all about metering. And when we get to the section on meters, we'll talk about when you have large flow meters and low flows, your accuracy fails pretty quickly. So there's a 36-inch flow meter on this pipeline, but depending on how we're operating the reservoir, there's times where we may be moving a relatively small amount of water. And when that happens, there's a set point on the flow meter that tells that automatic actuator on the valve to close, which will force the water coming out of the reservoir to go through the 12-inch line and therefore through the 12-inch flow meter, so we're more accurately metering lower flows. So it's all, again, having the ability to open and close a valve. In this case, it's not, I mean, we've got remote valves where we click a mouse. In this case, we don't even do that. It purely responds to a programmed set point based on flows within the pipeline. And when it flows drop to a certain point, the valve closes, and when they pick back up, the valves open. Another type of valve operation is hydraulic valves. These two valves are in a vault at the bottom of the 275 million gallon reservoir, so they're about 70 feet underwater. And there's a hydraulic system that will open and close those valves. There's also pneumatic valve operators, which are basically operating with compressed air. Both the hydraulic and pneumatic systems are a little less common. Motorized operators on all types of different valves at pump stations, reservoirs, are pretty commonplace in water distribution systems at this point. So that's kind of the motorized version. A lot of the manual operation of valves, and when we say manual, so there's no automatic control. There's the need to go out and exercise valves. And one of the things that we touched on when we talked about gate valves was the need to open and close those valves periodically in order to make sure that they are in good working order. If that exercise program doesn't happen, then those valves tend to fail. So we're going out and manually turning valves. There's different, when we say manually turning them, that means some different things. Old school, back in the day, used to always be, we'd take a valve key, we'd open up our lid in our valve can, put the key on the operating nut, and then we would rotate that key until the valve was open, and then we would close it again. Works, very tried and true, but it does take a toll on the human body. I have several long-term operators who have had shoulder surgeries, and it is not a stretch to attribute that to years and years and years of, amongst other things, turning these valves. So again, it works, but there's challenges that comes with it. One of the important things, although, about whether it be with a valve key or anything else, when it comes to operating these valves, one of the critical components of the operation is that we count and record the number of turns it takes to open or close that valve, and that we maintain a record of that. So if we're going to come out and open a valve, we want to be able to look back and say, okay, last year when we opened this valve, it took 24 turns. And that way we know, because it shouldn't change. There should be nothing different. So when we open or close the valve again, we should see the same thing. So counting and recording turns is just part of the documentation of this effort. When you're opening or closing that valve, if you're trying to close it and you can't get the valve to close properly, it won't seat, then one of the things that you can try and do is open up a fire hydrant to generate some flow and velocity, get some water moving, and then try and go up and down with the valve a few times, especially with those old double disc designs. Maybe that helps clean out that trough a bit. I've seen some operators, and when they're trying to get it to seat, that might use a little more force on the valve, maybe even a cheater bar that's more than likely to break the valve or injure the operator than anything else. So you got to be careful with these. They're a big investment in both the material of the valve itself as well as the installation costs. So we really don't want to find ourselves doing something silly that causes them to fail prematurely. Other than the valve key, there's a couple other ways. There are portable power operators where you simply are, instead of the human being turning the valve key, you've got a little motor that's doing it. So that is a popular piece of equipment because, again, it can save some wear and tear on the body. If they're designed properly, they can count the turns and record them as well. What you're seeing a lot more of nowadays is actual more kind of bigger scale valve operating equipment. We have something like you see here, a trailer that we towed, and it has a whole system to open and close that valve. It's got programming that will manage the amount of torque it takes to open and close the valve. It will count the turns. It's compatible with our maintenance management system. It's compatible with our GIS system, so it can record all that data for us and ensure that we're accomplishing the objective, we're operating that valve, and we're doing so in a manner that can keep faith with all of the kind of standard operating procedures that we've set down for the valve operating program. When it comes to inspection and maintenance, the benefits of a program, put simply, we verify the valves working properly. If we go out and exercise the valves, we will see that they're working. Valves that don't get exercised, systems that don't frequently exercise their valves, are setting themselves up for failure, are setting themselves up to have those isolation valves that don't isolate. In a perfect world, we would exercise those valves at least once a year. That may not be practical depending on the amount of resources an agency has to devote to an exercise program, because it really is about labor. It really is about how many people you have to go out and do that, to go out and perform that operation. I tried to do a survey a number of years ago and talk to a number of different agencies, and it was all over the map. There were agencies that said they were exercising their valves every year, and there were agencies that said they were never exercising their valves. So again, it's about individual choices that systems make. I think it's unquestionable, I don't believe it's debatable, that there are significant benefits in terms of maintaining the reliability of the valves to exercise them. But once again, there are challenges to maintain a program like that. In addition to verifying the function of the valve, we also will find out if valves are missing. So if we have plat maps, record drawings, atlas sheets, every agency might call it something different, but if we have some sort of system description documentation that says there's a valve at a certain location, and we go out there and it's not there, now we've got some investigation. More often than not, the city probably paved the street, covered over the valve, and that never got raised to grade, so we know we got to go get it back, or perhaps there's something else going on. But to the extent that there's a valve shown on our records that isn't there, we're going to want to know that, because if something goes wrong and we look at our plans and say, okay, we're going to go turn that valve, and go out there and find out in the emergency that it's not there, then that's a far worse condition. So having a regular maintenance program helps us figure out if we have problems like that. In addition to that, we'll also find oftentimes that the lid on the valve can is missing. It's gotten knocked out by a car. Perhaps it's gotten broken. That becomes a pure liability. Someone stepping in a hole. Sometimes even just a car hitting. We had a car that blew out tires because they hit a open valve can, or in one case where the valve lid flew out of the hole, and so you've got to keep an eye on these things to make sure that they're functioning properly, to make sure that we're cutting down on the potential for liability for the agency as well. So important benefits about the inspection and maintenance program. It's part and parcel of having the investment in that kind of equipment and those important critical components of a distribution system. And anything that important we need to pay particular attention to make sure that it's working properly.